Imagine you are standing in the middle of a forest with infinite trees. As you look around, every line of sight will eventually end at a tree. This is the same case with our universe. In a universe filled with infinite stars and galaxies, every line of sight should end on a galaxy, and therefore the sky should be filled with light. All logic tells us that the night sky should be bright, so how come it isn't? This is the question that Olbers Paradox strives to answer. There have been many attempts to solve this problem throughout history, most of which have been proved false. Johannes Kepler addressed the problem in 1610 with his island universe theory that the universe must be finite, not infinite. This continued to be an accepted resolution until the 1920s, when it finally became obvious that there were galaxies outside the Milky Way. In 1823, Olbers picked up on another theory, absorption. He believed that space is unlikely to be completely transparent and there must be some medium in space that absorbs light. Well, this theory fails as a resolution because if there was such a medium, it would heat up and, due to conservation of energy, end up glowing just as brightly as the light it absorbed. Now, a very interesting solution to the paradox was proposed by J.K.F. Zollner in 1872. He proposed that all three dimensions of space are curved, so space is unbounded yet still finite, so there is a limited number of light sources. Well, this explanation fails in practice because light rays would be deflected by gravity and eventually reach us from every direction. Now, in 1878, S. Newcomb presented his solution to the problem. He believed that the sky was not continuously luminous throughout, but rather split up by these ether voids that would block light from traveling through them. J. E. Gore further suggested that the Milky Way may be surrounded by such a void, blocking any light from outside. Of course, this idea fails because light would still bounce off the void and eventually fill the entire sky with light. Now to the resolutions we currently believe to be correct. First is a finite age energy resolution. In his 1848 prose poem Eureka, Edgar Allan Poe figured that some stars must be so far away that their light hasn't reached us yet. Johann Maedler also noted that the darkness of the night sky could be explained by combining finite light speed with a finite age. If the universe or the stars in it are young, then the sky simply has not had time to fill up with light. Put mathematically, light has a finite speed c, so there is an imaginary horizon around us at distance d equals ct, beyond which light from sources has not had time to reach us. Stars also have finite energy, and there is simply not enough energy in starlight to light up the whole sky. Harrison expanded on this resolution by calculating that stars only convert around 0.1% of their mass into light, and even if they did convert all of their mass into light, it would only be about as bright as moonlight as seen on Earth. The last resolution to the paradox is expansion. Space expands continuously, which stretches the wavelengths of starlight and spaces photons further apart, reducing the intensity of light as we receive from distant galaxies. This is accepted as part of the resolution to Olbers' paradox within the Big Bang theory, where it reduces the brightness of the sky by about 40%. Thank you so much for watching, and I hope you learned something today.